Good morning, friends and dear students. I am really very overwhelmed to be here for my course Engineering Thermodynamics. As of now, I have completed my module 2, but we need to solve some problems related to work and its transformation. So I have taken some problems from the book and we are trying to solve these problems, because this problem solving will give some better knowledge, better understanding of the concept which we have learned. So the work is, in thermodynamics, work is not like the previously we have learned in our physics that if you apply a force, if you take this thing and I am applying this force, it will move. So this force, applied force into distance moved, is a work. But in thermodynamics, work is not that. In thermodynamics, the resisting force, because if it is on the ground will give some resistance force. So this F, which you are applying into this how much distance, is not the correct statement for the thermodynamics. So for the thermodynamics, work is the resisting force into how much displacement it is moved. That is the work which we have to consider. And same thing is explained in the second law of thermodynamics. It is the raising of the weight. This Kelvin and the Planck statement says that raising of the weight. So what is the meaning of raising of the weight? Raising of the weight means working against the natural phenomena. Means gravity is acting downwards, but you are pulling. So this is called the raising of the weight. So it means it is a resistance, the force which is acting resistance to the body, like against the gravity. The work will be done. If you are falling any object from rooftop to the bottom, work is not done as per the thermodynamics. But as per the physics, it is done. Okay, so that is the difference between the thermodynamic work and the physics work that we have to take care of. So here I am going for one problem. Just a question. A DC electrical motor is used to operate a hoist mechanism in a crane. The motor is supplied with 300 volt and 10 amperes from a DC source for a period of 2 minutes. The torque provided by the motor to the hoist shaft is 250 Newton meter at a 50 RPM of the revolution. The hoist mechanism lifts a mass of 2.5 tons through a height of 5 meters. Calculate the work interaction for the DC source, motor, hoist and the mass. So here we have to find out the work interaction, how much work is obtained from each source, not for total. For DC source means battery, how much work, motor, how much work, hoist, how much work and the mass. So these all things we will be going one by one. Before that, we have to see that again there is a electrical motor. This electrical motor is operated by some battery or DC source. This motor is operating a hoist, and in this hoist there is a wire, and this wire is lifting. Like this is the wire and this is your weight and it is lifting. So this is the concept of this question. So how much work for each item, your DC source, your motor, your hoist and the mass, how much each one is doing the work or it is taking the work. So that we have to consider and that we have to try to solve this problem. So I will go first a diagram. In that diagram we will discuss, I will write all the part and then what are the things it is given in the problem, that also we have to discuss. So here we can see the solution here. This is here one DC source. This is the motor here. This is the hoist. And this is the mass. Okay, so from this DC source we are getting 300 volt of power supply, 10 amperes of the current, and that is for the 2 minutes. 2 minutes we can make as 120 seconds. Okay, so we can write 120 seconds. Okay, so next is the motor. So this power is given, this is the plus and this is the minus. So it is rotated. This is rotating this shaft. Here is the one hoist. This is the rope, and this is lifting 5 meter as per, and this RPM of this thing is 250 RPM. This is a 2 Newton meter, and this is the 50 RPM of this revolution per minute it is rotating. So we have to find out the work done by the battery. First case, this is the battery here, our power source. So this battery, we know that the work done by the battery is V into I into time. V is given 300 volt, temperature is 10 ampere, and time 2 minutes, so 120 seconds. So you will get 36 36000 joule. So we can make it as a kilojoule. So you will get here the 360 kilojoule. This is the work done by the battery. Now motor work done will be what? Because the work done here for the motor, it is the negative. When the work is entering any system, it is negative. So here battery of the work given to the motor by the battery is negative, and the work by the hoist, so W hoist. So we have to find out the work by the hoist. So we know that work by hoist is T into theta. This theta is rotational angle. So here we know that T is equal to 2 pi nt. So N is given, T is also given, torque, T is a torque, N is a revolution or RPM, so 2 pi nt. So it is RPM, N is revolution per minute, we have to change to the revolution per second. So here 2 into 3.14, here it is given 50 RPM, so 50 by 60 revolution per second into 250. So work hoist is equal to T into theta. So theta, so here this we can write is equal to this P into T, and this is, we have got that 1308.9 watt into time is 120 second. So we will get 157 kilojoule. So work which is obtained for the hoist is 157 kilojoule. So this we have achieved. This one we got it. This one also we have got. So now this minus 360 plus 157. Then you will get the work on motor. Work on motor, how much balance of the work? So minus work of the battery plus work of the hoist. So the battery is generating minus 360 kilojoule plus 157 kilojoule. It means minus 203 kilojoule of work is there inside your motor. This much work is still existing inside the motor. Now, next we will see that interaction of work of hoist. So work is done by the motor and the hoist. in doing work for the mass. So here we can see that minus T into theta plus mgh. So minus T into theta, because it is minus, because this is going inside the hoist. So minus P into T plus mgh. So we have got this minus P into T, we got minus 157 kilojoule plus M 2.5 ton, so 2500, G is a 9.81 into 5 is the height, where H is a height is equal to 5 meter and mass is equal to 2.5 ton or 2500 Newton. Okay, so here minus 157 kilojoule plus, if you just do this all calculation, you will get minus 157 kilojoule plus 120.6 kilojoule. So here you will get minus 34.4 kilojoule. So this is the work interaction of the hoist is minus 34.4 kilojoule. So this is another answer which we have got from this discussion. Hope these things are very much clear, and if any problem, I will give the email. You can send to me as and when if you required. Next we will see work on mass. So work on mass, so this work on mass is equal to minus mgh minus 2500 into 9.8 into 5, you will get minus 122.6 kilojoule. So sum of all the mass must be 0. Sum of the all the mass, sum of all the mass work must be 0. So work of battery plus work of motor plus work of hoist plus work of mast should be 0. So work of battery, it is giving positive 360, motor is 203, minus 34.4 by the hoist and minus 122.6. If you sum these things, you will get 360 minus 360 is equal to 0. Hence work and energy is conserved. So here work, whatever energy we supplied from the battery, this is the battery supplied. This is the energy which is supplied by the battery. This work, this energy equal to work, and this is the work done by each and every item in the system. So summation of this thing is 0. So our first law of energy, that is the energy is conserved, is correct. Now I will go with another problem, that is the numerical problem. So tank A and a piston cylinder arrangement B are connected through a pipes as shown. The piston is frictionless. Tank A contains nitrogen at 300 kilopascal and its volume is 0.3 meter cube. So this is the pressure. Here is 300 kPa and the volume is equal to, capital V is equal to 0.4 meter cube. This is given. It requires 150 kilopascal to lift the piston. So here to lift we need 150 kilopascal to lift this piston. As the connecting valve opens, this is the valve. As and when you open this, valve is opens nitrogen flows. So here the system is nitrogen. Inside this is the system and here is the nitrogen. As you open this valve, nitrogen flows into the piston cylinder. Nitrogen will move here inside this arrangement B and attains a steady state after some time. So after some time it has reached here. So here is a 150 kilopascal. It will steady state will be reached. What is the final pressure and the work interaction for nitrogen if the initial and the final states are related to PV is equal to constant, where P and V are represented by the pressure and the volume of the gas and C represents the constant. So this is the condition and we have to solve this problem. So how to go about? Again, we have to draw the diagram, write whatever things are given. Then we have to understand that how these things will process, and then we will find out the solution. So here I have drawn here the red line is a system and this system is nitrogen. This is the tank A. Tank A, the P1 is 300 kilopascal and V1 is 0.4 meter cube. Here is a valve. If you open this valve, the nitrogen will move from here to here. The steady state condition for this is 150 kilopascal only, it will lift. So that is the given condition and we have to find out the pressure and other parameter. So initially mass is only in the tank A, that is A with the nitrogen. As system shown by the dotted line here, after opening of the valve, some mass goes to the cylinder B here, but mass will be constant. The sum of this A and B will be constant. So the total system you can add like this. This is your total system. This is your system. So system should be in the quasi-equilibrium. The valve make a flow process. So here we will have the flow process. So in this given state 1 is P1 is equal to 300 kilopascal and the V1 is equal to 0.4 meter cube. So we have to see that what will be the state 2. So piston will only move when pressure at the bottom in B is 100 kilopascal. It is given. It is constant pressure process. PV is equal to C. So directly we can use the equation P1 V1 is equal to P2 V2. P1 is 300 kilopascal. V1 is equal to 0.4 meter cube. 150 into V2. So we can find out the V2 is equal to 300 into 0.4 by 150. We got the 0.8 meter cube. So V2 here we got P2 is given, that is 150 kilopascal. We got V2 is equal to 0.8 meter cube. This state 2 we have achieved. Now we have to get some other things. So work done. Work done by the piston. So 1 to 2. This is the 1 and this is the 2. So it is PdV. Work done 1 to 2 is equal to 1 to 2 PdV. This is equal to P 1 to 2 dV. P V2 minus V1. Here P is a constant. So, and this P is a constant is 150 kilopascal. So here we will write P is equal to 100 kilopascal into V2 minus V1. V2 we have just now got 0.8 minus 0.4 meter cube. So we got here 60 kilojoule. Now work done against atmospheric pressure. If here is atmospheric pressure we are also considering, then how much work is done? And normally the atmospheric pressure is 100 kilopascal. So work of atmosphere is 1 to 2 PdV. P into V2 minus V1, and this is against to this. So here will be minus because it is trying to reduce the volume. So minus 100, 0.8 to 0.4, you will get here minus 40 kilojoule. So net work done, that is delta W is equal to work done by 1,2 plus work done by the atmospheric plus work done by the piston. But it is assuming that work done. So this is the 60 minus work done by the atmosphere is 40 plus work done by the piston is equal to 0. So how much work done by the piston is equal to minus 20 kilojoule. Means it is also trying to pull down. Piston pull down due to the gravity of the piston. So how much height piston will travel? If we want to find out how much height, so we can find out that this is a minus 20 kilojoule divided by m into g. So if you know the mass of the piston, you can find out this height by this equation. So in this way, you can find the answer, and you can also understand that how these things are done and how these processes are worked. So I think it is very interesting. So if you see in the question, what is the final pressure? And so the final pressure we have got is 150 kilopascal. It is also given, but it will be the final pressure here. And next it is asking that work interaction for nitrogen. So work interaction we have got here from the nitrogen, we are getting 60 kilojoule. Then it is work interaction against the atmospheric, we are getting the minus 40 kilojoule. Work done by the piston, we are getting minus 20 kilojoule. And how much distance it will travel, that also, however, it is not asked in the question, but you can do it by H is equal to minus 20 kilojoule by mg. If you assume as a 1 kilo, so 20 by 1 into 9.8, nearly 2 meter. If it is 1 kilojoule and g is equal to 10. So here 20 kg divided by 20, so here 1 meter. So height will come 1 meter, your piston will tell if shift, if it is the 1 kg. If it is the 2 kg, it is 5 meter. If it is the 5 kg, if it is the 1 kg, it is 1 meter. If it is the 2 kg, it is half meter. Like this, it will reduce the travel distance. So in this way, we can calculate the things, we can find out the things of the required system. These are the references which I have taken from P.K. Nog, Engineering Thermodynamics, Tata McGraw-Hill's 4th edition, Eunice Sengel, Michael A. Bowles, Thermodynamics and Engineering Approach, Tata McGraw-Hill's. Also NPTEL lecture from Dr. Mishra, IIT Kanpur, I am referring. You can also refer, very good lecture. Also Professor Suman and other very good professors are there from IITs. They are very nicely explaining all these issues. Any questions, you are welcome to ask to my email. My email is yddwivedi@gmail.com. You are also, I request you to like and subscribe this channel, and also give comment if you want any further explanation or the query. Thank you very much for the joining. See you soon with my next module of the lecture. Okay, thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.